Up to this point, we've been working on factoring quadratic expressions, also known as trinomials. In this particular section, section 4.6, we are going to go through and we are going to solve quadratic equations. But before we do that, let me just review going through and solving an equation. This is not a quadratic equation, this is a linear equation. So I'm given 3x plus 5 is equal to 11. If I want to go through and solve that, we need to work on getting the x all by itself on one side. So I'm going to subtract 5 from both sides. When I do that, I'm left with 3x is equal to 6. Then I'm going to go through and divide both sides by 3, and I will get a final answer of x is equal to 2. This is when you have a linear equation. Quadratic equations, though, have to work a little bit differently. Here is a quadratic equation that we're going to work on solving. X squared plus 5x plus 6. In this quadratic equation, we cannot get the x, I should say, all by itself on one side because we can't combine the x squared with the 5x because they are not the same terms. So if I want to go through and I want to solve this, the very first thing to do is to just factor that quadratic equation. When I do that, I'm going to get an x and an x. I'm going to get a 2 and a 3. So I have it factored down to, in parentheses, x plus 2 times x plus 3 is equal to 0. This equal to 0 part is very important when going through and solving quadratic equations by factoring. Because it equals 0, that means that either the x plus 2 has to equal 0 or the x plus 3 has to equal 0 because I am multiplying these two factors together. And the only way to get 0 when you multiply two numbers together is that one or both of the numbers have to equal 0. So what I'm going to do is I'm going to go through and I'm going to set each one of these factors equal to 0. What does x have to be if x plus 2 is equal to 0? Well, now in this particular case, I would go through and subtract 2 from both sides. So I would get x would have to equal negative 2. If x was negative 2, then that factor, x plus 2, would be equal to 0. I'm going to do the same thing with the x plus 3. I'm going to set x plus 3 equal to 0. In order to do that, I need to go through and subtract 3 from both sides. And now I have x is equal to a negative 3. Which means if I put negative 3 into this factor, negative 3 plus 3, I get 0. So there are two possible answers for this quadratic equation when it's equal to 0. Either x is equal to a negative 2 or x is equal to a negative 3. Let's look at another one. X squared subtract 4x subtract 21 is equal to 0. Notice that I already do have this equal to 0. As I go through, I'm going to factor this. So if I factor this, I'm going to use the reverse of the FOIL method. It's equal to 0. It would be an x and an x. Because one of these is a subtraction, because this is a subtraction, one of these has to be addition, one of these has to be subtraction. And as I go through this, I would find out that it would be x minus 7 and x plus 3. So now once again, that means that either the x plus 3 has to equal 0 or the x minus 7 has to equal 0. So I'm going to set each one of those equal to 0. If I set x plus 3 equal to 0, I'm going to subtract 3 from both sides, and I'm going to get x is equal to a negative 3. So if x is equal to negative 3, that factor would equal 0. If I set x minus 7 equal to 0, I'm going to add 7 to both sides. I'm going to get x is equal to 7. If x is equal to 7, x minus 7 is equal to 0. So my two answers in this case are x is equal to a negative 3, and x could also be equal to 7. Remember, that would mean that if I put negative 3 in for x in both of these areas and go through and perform the calculation, I would get 0 for an answer. It also means that if I would put 7 in for the x and 7 in for this x and perform the calculation, I would also get 0. One thing to watch out for is if your quadratic equation is not equal to 0, as in this example, x squared subtract 5x is equal to 50. In order to solve quadratic equations by factoring, the one side does have to equal 0, so that when you multiply the two factors together, you can set them both equal to 0. So in this particular case, the very first thing I would do is I would subtract 50 from both sides. If I subtracted 50 from both sides, I would get 0 on the right-hand side, setting that quadratic equation equal to 0, and x squared subtract 5x subtract 50 on the left side. Now I'm just going to go through and continue to do what I was doing in the previous two examples. I'm going to stop here for a moment, let you factor that, see if you can figure out the answer, and then turn this back on again and you can check your answer, please. Okay, hopefully you had some time to go through and finish this problem. If I'm going to factor this, I'm going to have an x and an x. I know because this is a subtraction, one of these has to be addition, one of these has to be subtraction. And what I will find will work is if I have x plus 5 and x minus 10. So now I just need to set each one of these equal to 0. If x plus 5 is equal to 0, I'm going to subtract 5 from both sides. So I'm going to have x is equal to a negative 5. That's going to be one of my answers. If x minus 10 is equal to 0, I'm going to add 10 to both sides, and I'm going to get x is equal to 10. So the two different answers are x is equal to negative 5, and x is equal to 10. Up to now, all the quadratic equations we've talked about have only had a coefficient of 1 in front of the x squared. This one has a 2, but it works exactly the same way. The first thing I have to do is I have to make the right-hand side equal to 0. So if I go through and subtract 3 from both sides, I'm going to have 2x squared subtract x subtract 3 is equal to 0. I'm going to do the factoring here fairly quickly because I want to get to the point for this particular section that I want to talk about. So I have 2x squared subtract x subtract 3, and if I factor that, I will get 2x subtract 3 and x plus 1 is equal to 0. Once again, I have to set each one of these factors equal to 0. So if I set the first one equal to 0, I have 2x subtract 3 is equal to 0. I'm going to have to add 3 to both sides, and I'm going to get 2x is equal to 3. Then, dividing both sides by 2, I'm going to get x is equal to 3 halves. So one of the answers is x is equal to 3 halves. For the other one, if x plus 1 is equal to 0, then I'm just going to subtract 1 from both sides. Subtract 1, I'm going to get x is equal to a negative 1. So the two possible answers, x is equal to 3 halves, x is equal to negative 1. I just want to remind you, remember that means that I could put both 3 halves and negative 1 in for the x's in the original problem, and in this case I would get an answer of 3. Let me do just one more example. X squared plus 5x equals 0 may not look like it's a quadratic equation, but it is because it does have an x squared. What it's missing is that third term, commonly known as c. So in this one, I'm not going to factor it exactly the same way, but now I take a look at both of these terms and I have a common x. So I'm going to factor out an x in both of these terms. When I do that, I get x times x plus 5 is equal to 0. So now I'm just going to do the same thing. I'm going to set this factor x equal to 0. So one possibility is that x is equal to 0. I'm also going to set x plus 5 equal to 0. If x plus 5 is equal to 0, the other answer would be x is equal to a negative 5. So I have two answers for this one. X is 0 and x is negative 5. This concludes the video on section 4.6. Please remember, you just need to go through and practice, and as always, ask me when you have questions. It's my job to help you. Please make sure you ask. Thank you.